13.3 Day 2, evaluate trigonometric functions of any angle. Today what we're doing is we will be expanding on what we worked on yesterday, which was finding reference angles after drawing our angles in standard position. Now we will take those reference angles and actually use trig functions and evaluate those trig functions for that, or using those reference angles, excuse me. Before we get into that, let's review these special right triangles again. Notice I have them here with radians initially. In this first special right triangle, we have pi over 4 as one acute angle. This would also be a pi over 4 because this is a 45, 45, 90 triangle in degrees. You can tell by the sides being x and x, the two legs being the same, and the hypotenuse being x times the square root of 2. The second triangle is a 30, 60, 90. Your 30-degree angle is your pi over 6. Your 60-degree angle, you would be able to label pi over 3. Across from the pi over 6 is always the short leg. Across from the pi over 3 is the long leg. And then across from the right angle is your hypotenuse. Now, in these triangles up here, the pi over 4, if we want to convert that to degrees, we would take pi over 4, multiply it by 180 over pi, either cross-reducing or multiplying together and then reducing. We would find that those are both 45 degrees, like I had mentioned before. So in our third triangle, we could label both of those as 45 degrees. So you have the special right triangle using radians and the same special right triangle now using degrees. For the pi over 6, if we convert that to degrees, we would figure out that that's 30 degrees. So this top angle in our last triangle is 30 degrees. The pi over 3 would convert to 60 degrees. So again, you have your 30, 60, 90 triangle, both shown in degrees, the fourth one, and radians, that second one. We could also label the short leg, long leg, and hypotenuse of that 30, 60, 90 triangle. So now using those special right triangles, we want to first evaluate all of these trig functions for 45 degrees. So we're going to use this third triangle here, the 45, 45, 90 special right triangle. So if we are going to evaluate the sine of 45, opposite over hypotenuse, we have to start out with x over x squared root of 2. Then we have to rationalize that, and we would reduce out the x's. So sine of 45 is square root of 2 over 2. Cosine, we would be doing the same thing. Adjacent over hypotenuse. Adjacent is still x, same as opposite. Reducing the x's and rationalizing, we would again find square root of 2 over 2. The tangent of 45 is just x over x, opposite over adjacent, so that would equal 1. The cosecant of 45, you have to remember cosecant is a reciprocal of sine, so we can do hypotenuse over opposite, x times the square root of 2 over x. The x's would reduce out, so we know that this would be just the square root of 2. Then we have secant of 45, the reciprocal of cosine, so that would be hypotenuse over adjacent. Again, it's the same as cosecant since these are congruent angles. And then cotangent, the reciprocal of tangent, x over x, is just x over x, so that also reduces to 1. Now we'll do the same thing, just focusing on sine, cosine, and tangent, but now for the two different angles of the 30, 60, 90 triangle. So if we work from the 30-degree angle and we do sine, opposite over adjacent, the short leg is the opposite, opposite over hypotenuse. The short leg is the opposite and the hypotenuse is the hypotenuse. So that would be x over 2x, and if we reduce the x's out, we would get 1/2. That is the exact value for sine of 30. Cosine of 30, your adjacent would be your long leg, so that's the x times the square root of 3. Hypotenuse is still the 2x. So when we reduce, we just get square root of 3 over 2. The exact value of cosine of 30 is square root of 3 over 2. The tangent of 30, the short leg is your opposite, the long leg is your adjacent. So you have x over x squared root of 3. Have to rationalize that and reduce the x's. You would find that you'd have square root of 3 times 3. The sine of 60 now. Opposite over hypotenuse, now working from the 60-degree angle. The long leg is the opposite. So you have x times the square root of 3 over 2x. So that reduces to square root of 3 over 2. The cosine of 60 means the short leg is the adjacent. The hypotenuse is still 2x. That would reduce to 1/2. And the tangent of 60, opposite is the longer leg, and adjacent is the short leg. So x squared root of 3 over x would reduce to just the square root of 3. What you've just done here is evaluate these trig functions for these specific angles and found the exact values without using any calculator. This is what we're going to be working on the rest of this lesson. So to evaluate the trig functions of angles not in the first quadrant based on a reference angle, we need to draw the angle, like we've talked about the last few days, and find the reference angle, which, remember, reference angle is always between the terminal side and the x-axis. Your second step is to draw a triangle to the x-axis, and this always ends up being a right triangle. And we're going to label those with variables based on the reference angle. And then from finding the reference angle, we would be able to tell which special right triangle we would be using. And those would be the variables that we're labeling with. One hint with this, or one suggestion: if you have a 30, 60, 90 triangle, whether it's in degrees or radians, doesn't matter, might not be a bad idea to label the short leg, long leg, and hypotenuse as kind of a little helpful tool for yourself. And then your final step is to evaluate or find your trig values. One thing you need to make sure of is that you're watching the signs when you do this. You will have some positive and negative values that you need to be paying attention to. So as we go through these examples, if you need to pause the video at any time to make sure you get all the information down, especially when you're drawing the angle and your triangle and you're labeling them, please make sure you do. So if we need to evaluate the tangent of 45, the first thing we have to do is we have to draw 45 degrees in standard position. So it's a positive, so it's opening counterclockwise. Vertex is at the origin. I found the reference angle already as well. It's easy when it's in the first quadrant because the angle itself is the reference angle, 45 degrees. So now what I'll do is I'll draw that triangle back to the x-axis. So here's my vertical line, creating my right triangle. And now, since this is a 45-degree reference angle and the right angle from the perpendicular line coming down to the x-axis, I know this is a 45, 45, 90 special right triangle. So I can label the three sides of this with the x and the x for the two legs and the x squared root of 2 for the hypotenuse. Once I have this picture completed, I can actually evaluate the tangent of 45. So tangent of 45, opposite over adjacent, x over x. That would simplify to be just 1. So that gives you a little bit of an example of the process used to evaluate these trig functions and get exact values. Excuse me. So now if we want to evaluate the tangent of negative 210, we need to first draw negative 210 degrees in standard position. So that's a clockwise rotation because it's a negative value. We need to find our reference angle. So just like we have talked about in the past, finding a reference angle, you take the two values that your reference angle is in between and you subtract larger minus smaller. So negative 180 minus negative 210 gives me a positive 30-degree reference angle. So I know this angle here is 30 degrees. Now I can draw my triangle. There we go. So always coming back to the x-axis. You can put that anywhere in this angle as long as it's perpendicular to the x-axis. Now we know this is going to be a 30, 60, 90 triangle because we have a 30 degree and a 90 degree. The third one has to be a 60 degree angle. So again, the little hint up here, label the short leg, long leg, and hypotenuse might be helpful. Short leg is opposite the 30 degree angle. Long leg is opposite what would be the 60 degree angle. Hypotenuse always opposite the right angle. Now label the sides of this triangle based on that special right triangle from the top of your notes. Be careful this time now. You'll notice the long leg here, I have negative x times the square root of 3, not positive x times the square root of 3. That's because that triangle is on the left side of the y-axis. All of the values on the horizontal pieces on the left side of that will be negative. The vertical short leg here is still positive because we're moving up from the x-axis. And then your hypotenuse will always be positive. Once you have this picture completed, you can start evaluating the tangent of negative 210. Opposite over adjacent from your reference angle. The short leg is your opposite. The long leg is your adjacent. So you would have x over negative x times the square root of 3. When you simplify the x's out and then rationalize, you would come up with the tangent of negative 210 is negative square root of 3 over 3. If we want to evaluate the cosine of 315, again, the first step is to draw your angle in standard position. This one is again positive, so we are rotating counterclockwise. We need to find the reference angle now, so between 360 and 315, larger minus smaller, that's a 45 degree reference angle, so I can label that. I can draw my triangle by drawing that vertical line back to the x-axis so that it's perpendicular. So we now have a 45, 45, 90 triangle. Labeling the sides of this triangle based on our special right triangles. We would have x for the horizontal leg. We'd have negative x for the vertical leg because it's coming down from the x-axis. And then x times the square root of 2. Again, the hypotenuse is always a positive value. So from here, we can write that the cosine of 315 adjacent over hypotenuse, so x over x times the square root of 2. Simplifying the x's and rationalizing the denominator, we would find that the cosine of 315 is square root of 2 over 2. Last one with degrees, we have to find the sine of 240. So the sine of 240, first thing we have to do is draw in 240 degrees in standard position. Find the reference angle. So now, again, we're always going back to the x-axis, so it's between 240 and 180. Larger minus smaller tells us that we have a 60 degree reference angle. Now we draw back to the x-axis to make our right triangle. Since this is going to be a 30, 60, 90, might not be a bad idea to again label your long leg, short leg, and hypotenuse. And then once you have those labeled, hopefully you can easily label the actual side lengths now. This time, the horizontal leg is going left from the origin, so that's going to be a negative value. So that's negative x. The vertical leg is coming down from the y-axis, so this is a negative x squared of 3. And again, the hypotenuse is always positive. This is what I was referring to on the front side of your notes, where I said make sure you're watching your signs. So now evaluating the sine of 240, from the 60-degree reference angle, opposite over hypotenuse, negative square root of 3 over, negative x square root of 3 over 2x. The x's would reduce out, and you would be left with negative square root of 3 over 2. Same idea with the rest of our examples as the previous 4, except now we have to deal with radian angle measures. We've practiced drawing radian angles. So that's the first step again. There's the drawing of 11 pi over 4. Now you have to find your reference angle. So between 11 pi over 4 and 12 pi over 4, larger minus smaller, you'd be left with pi over 4 as your reference angle. Now if you draw back to the x-axis to create your right triangle, this would be a 45, 45, 90 triangle, or a pi over 4, and this 90 is pi over 2. So labeling the sides, your horizontal leg would have to be negative x because you're coming to the left. You're going up with your vertical, so that's positive, and then again, your hypotenuse is always positive. Now, if I'm supposed to evaluate cosecant, personally, I think of cosecant just as the reciprocal of sine. So I think about it as sine being opposite over hypotenuse. Then that reminds me that cosecant would be hypotenuse over opposite. So hypotenuse would be x times the square root of 2. Opposite from your reference angle would just be your x, which would reduce to just the square root of 2. Now, if we have to find a cotangent of 5 pi over 3, go ahead and draw that in standard position. Ooh, that got moved. Sorry about that. When you draw that in standard position, you should find that terminal side is in the 4th quadrant. See how bad the rest of this is. See if these got moved. Oh, it's still there. So there I made my right triangle. Have to find my reference angle. So from 5 pi over 6 back to 6 pi over 3. That's a typo. This should be 5 pi over 3, not 5 pi over 6. 6 pi over 3 minus 5 pi over 3, which is what this should be. This should be a 3 in the denominator also. My reference angle is pi over 3. Now, looking at the top of our notes on the front side, if I have pi over 3, that's really a 60-degree angle. So this is a 30, 60, 90 triangle. I want to label my short leg, long leg, and hypotenuse, and then use the different side lengths. Again, paying attention this time to your longer leg, since you're coming down, is a negative x times the square root of 3. So evaluating cotangent, I know tangent is opposite over adjacent, which means cotangent, the reciprocal, is adjacent over opposite. So that gives me x over negative x squared root of 3. Reduce out the x's and rationalize, you get negative square root of 3 over 3. Next one is secant of 13 pi over 6. Go ahead and draw 13 pi over 6 in standard position. When you draw that, you should find that it's in the 1st quadrant. Your picture should look like this. Finding your reference angle from 13 pi over 6 back to 12 pi over 6. You'd have pi over 6 when you do larger minus smaller. You can draw in your line going back to the x-axis to make your right triangle. Now, if this is pi over 6, we know that's a 30-degree angle. So you have your short leg opposite the pi over 6. Long leg would be opposite what would be the pi over 3 here. in this top corner angle, and then your hypotenuse opposite your right angle. Now you can label your sides. Notice they're all positive now because you have your horizontal coming to the right, your vertical going up, and then hypotenuse again, always positive. All right, now if I'm trying to evaluate secant, I know secant is the reciprocal of cosine. If cosine is adjacent over hypotenuse, secant has to be hypotenuse over adjacent. So that means I would start out as 2x over x square root of 3. Now I would reduce out the x's, but I would also have to rationalize this square root of 3 in the denominator. I would end up with 2 square root of 3 over 3 when I do that. Our final one, we have the cosine of 4 pi over 3. So we need to first draw that in standard position. So this ends up being in the third quadrant. The triangle always goes back to the x-axis. Find your reference angle. 4 pi over 3 minus 3 pi over 3 is just pi over 3. So now this is a 30, 60, 90 triangle. So labeling short leg, long leg, and hypotenuse. Then labeling the side lengths. Now your horizontal is going left and your vertical is going down. So that means they both have to be negative values. So I have negative x on the short leg, negative x squared root of 3 on the long leg. And one more time, the hypotenuse is always positive. Now cosine is one of our original 3, so we don't have to worry about doing the reciprocal of anything. Cosine is adjacent over hypotenuse, so that would be negative x over 2x, which would reduce to negative 1/2. So once again, if you need to go rewatch any part of the video to maybe clear up something that you aren't quite sure on, please make sure you do so. Otherwise, you may now go ahead and get started on your homework. Again, make sure you are checking your answers to make sure you are able to complete your problems correctly.